Thevenin's and Norton's theorems allow us to model a linear circuit as either a voltage source in series with a resistance or as a current source in parallel with that same resistance. This implies that either of these combinations can be converted to the other. This conversion process is called a source transformation. Thevenin's theorem says that the two terminal characteristics of a linear circuit can be modeled as a voltage source, VOC, in series with the circuit's Thevenin resistance, RTH. VOC is the voltage that would be seen across the circuit's terminals if the terminals are open-circuited. RTH is the equivalent resistance seen across the terminals of the circuit with all of the independent sources in the circuit killed. Norton's theorem says that the same circuit can be modeled as a current source, ISC, which is the current through the terminals if they're short-circuited, in parallel with the circuit's Thevenin resistance. Thevenin's theorem says that the voltage-current relationship at these terminals is that the voltage across the terminals is RTH times the current I plus VOC, the open circuit voltage. Norton's theorem says that the same voltage-current relationship can be written as I is equal to V over RTH minus the short-circuit current. That means that these two equations are the same since they both describe the same circuit. Combining Thevenin's and Norton's theorems leads to what's called a source transformation. A source transformation allows us to convert any voltage source that's in series with a resistance to a current source in parallel with the same resistance, and vice versa. To show how to do this, I'll first solve the equation of Thevenin's theorem for the current. So the current is equal to the voltage divided by RTH minus the open circuit voltage divided by RTH. Since this current is the same as the current in Norton's theorem, this is equal to V over RTH minus the short circuit current. These two terms cancel. So ISC is equal to VOC over RTH, or equivalently, VOC is equal to RTH times ISC. A source transformation allows us to exchange a voltage source that's in series with a resistance with a current source in parallel with that same resistance. Likewise, a current source that's in parallel with the resistance can be exchanged for a voltage source in series with that resistance. So this configuration of circuit elements can be converted to this. If this current source's current is set equal to the original voltage divided by the resistance. Likewise, this configuration can be converted to this one if the voltage source is set equal to the original current times its resistance. Making this exchange can sometimes be useful in circuit analysis, especially if it creates a circuit where circuit reduction techniques such as voltage and current dividers become applicable. Now let's do an example of a circuit analysis using source transformation techniques. This circuit is relatively easily analyzed by either nodal or mesh analysis, but it's also amenable to source transformations. I have two voltage sources, both of which are in series with resistances. I can convert both of them to current sources in parallel with the same resistance. So this combination can become a current source in parallel with a resistance. The resistance doesn't change, it's 3 ohms, and this current is 9 volts divided by 3 ohms, or 3 amps. This combination is connected here. It's a current source. Its direction is going to be this way because the positive terminal is down here on this voltage source, and its current's going to be 12 volts over 6 ohms, or 2 amps. And that is in parallel with this 6 ohm resistance. And this is the voltage V that we want to find. If I do KCL, the sum of these two currents is 1 amp going in this direction. So 3 amps minus 2 amps is 1 amp going this direction. These two resistors are now in parallel. I can combine those to a single 2 ohm resistor. The voltage that I want is the voltage across that 2 ohm resistor. By Ohm's law, V is equal to 1 amp times 2 ohms. So V is equal to 2 volts. Source transformations can be useful, but make sure you don't use them in cases where they don't apply. Always double check that the voltage source is in series with the resistor or that the current source is in parallel with the resistor before attempting a source transformation.